Hello and welcome back to Introduction to Geology. My name is Paul Eric and I teach physics, astronomy, and geology at Ozarks Technical Community College in Springfield, Missouri. So this series of videos is going to be a review for the Unit 3 lecture exam. And so we're going to be going over Lesson 8 on earthquakes, Interlude D on geophysics, Lesson 9 on structures and mountain building, Interlude E on fossils and evolution, Lesson 10 on how do we know how old the Earth is, and then Lesson number 11, the actual history of the Earth, Interlude F on landscapes and the hydrological cycle, and then finally Lesson 13 on landslides and mass wasting. So you'll notice that some of these episodes have an asterisk next to them, so Interlude D and Interlude E and Lesson number 11. So those are the ones that are optional videos, and so what you want to do is check with your instructor to find out if those particular episodes are going to be on the Unit 3 lecture exam. So what I'm going to do is I'm going to cover all of these lessons as though they're going to be on the exam, but you find out whether or not those particular segments are going to be on it or not. So we're going to start off with lesson number 8 on violent pulse earthquakes. And so in your textbook, that is going to be chapter 7. And so we'll start off with some definitions. So definitely for the exam, you got to know the difference between the epicenter and the hypocenter. So remember what a hypodermic needle does. So a hypodermic needle goes under the skin. So the hypocenter is going to be under the ground. On the other hand, think about your epidermis, which is the upper layer of your skin. So then that means that the epicenter is going to be the point at the surface directly above the hypocenter. Okay, then what causes an earthquake? So you should just be familiar with these different ways of making an earthquake. Now the primary way of making an earthquake is going to be the faulting. So that's going to be the big one. So where you got two pieces of rock that are sliding past each other and they get caught, and then pressure builds up on it until finally they move, that's going to generate an earthquake. But also you can get earthquakes from the intrusion of magma into the ground. And then also a landslide can trigger a small earthquake. Man-made explosions, again, can trigger small earthquakes, and then impacts of space debris. You should know about the elastic rebound theory. And so this is very simple. If you take a pencil and you start to apply a force to it, at first it's going to start to bend. If you relieve that force, then the pencil is going to return back to its original shape. But if you continue to apply force to it, eventually it's going to break. And when it breaks, it's going to release energy in the form of an earthquake. So what is going to determine the energy of an earthquake when it does happen? So it depends on the length of the fault, depends on the area of contact between the two surfaces. It is going to be determined by how much displacement occurs. So did the rocks, did they break a big amount, or did they break just a little bit? Okay, it also is going to depend on how much force was being applied to the fault and what was the kinds of rocks that eventually broke. Now, very important that you know the P waves, the S waves, the L waves, and the R waves. So P is going to stand for primary waves because they are the first ones to arrive. S stands for secondary because they are going to be the second kind of waves to arrive. Okay, then L waves stand for love waves, and R stands for Raleigh. Notice that L can also stand for left to right, because that's what's going to cause the ground to move back and forth from left to right. And then R is going, you can think of that as rolling, because think of how water rolls in the ocean. So that's the way that those kinds of earthquakes are going to move the ground. The P waves are going to make a pulse. So if you take a slinky and you give it a shove, then the pulse is going to travel down the slinky. So that's a P wave. And then if you take the slinky and you move it back and forth like this, that's a shear wave. So all of this information is summarized here. And the first ones to arrive, very important, is going to be the P waves. And then the S waves are going to be the second ones to arrive. Another thing is which kind of wave causes the most amount of destruction. So that's going to be the L waves, the love waves. Another very important thing is which kinds of waves can travel through a liquid. Because in our next review lesson, we're going to be talking about geophysics and how we can use the P waves, which can go through a liquid, and then the S waves are going to be stopped by a liquid. And we're going to use that property to map the inside of the Earth. So make sure and know that the P waves can travel through liquids, but the S waves cannot. Okay, now this is just the formula that shows the reason why the P waves are going to arrive first and then the S waves are going to arrive second. So if you look at the formula, you'll notice that the velocity of the P wave has two parts to it. And so when you plug numbers into those two parts, that's the reason why that velocity is going to be larger than the S wave. Now, you don't need to know about the formulas for the exam. You don't need to know about the speeds. You should know that a rock that is solid is going to transmit waves easier than like sand will. So that would be something that you would need to know for the exam. Okay, you got to know what a seismograph is. And you can see that there are two kinds of seismographs. So you can have one that is going to be able to measure P waves, and you also have one that can measure the S waves. And you also have a kind that can measure the L and the Raleigh waves as well. But just know that a seismograph is going to be measuring the strength of an earthquake. The more it makes the needle jump up and down, the stronger the earthquake is going to be. Okay, how do you locate earthquakes? So by using the time delay between the S and the P waves. So if you subtract those two waves, that time difference is going to be proportional to how far away the earthquake occurred. So you should be able to use a graph like this, measure the time of arrival of the S and the time of arrival of the P, and then subtract the two, and then find that time difference on the graph, bounce it off the S minus P curve, and then find out how far away that earthquake occurred. So make sure to be able to do that for the exam. And then the idea of you have to have three seismic stations in order to be able to locate the epicenter. So that's going to be called triangulation. Triangle, three sides. You need three seismic stations to be able to locate the epicenter. All right, let's take a break. And when we come back, we will talk about where are earthquakes found.